Good afternoon, everyone. Today we're going to solve a few exponential equations. And for the first one, we have 2 and we have 8 and we have 4, really. And so what we're going to do to solve for our unknown value of x, which is in our exponents, is we're going to write everything under a common base. And so we can write 2, 8, and 4, all as powers of 2. We'll call that our common base. And so to do that, we're going to write 2 to the x as just 2 to the x. And then we're going to write 8 as 2 to the power of 3. And then we're going to write 2 to the power of 3 to the power of 1 minus x. Okay? Now on the other side, we have 1 over 4. And in an attempt to write everything with a common base of 2, we're going to write 1 over 4 as 2 to the power of negative 2. Okay? And now it's just going to be an application of our exponent laws, which hopefully we're familiar with. So when we multiply by the same base, well, first of all, we have a power to a power in this term here. So we'll have 2 to the x times 2 to the, when we have a power to another power, we multiply the exponents. And so we'll have 3 times 1 minus x. And that's equal to 2 to the negative 2. I'll finish off over here. Now, let's multiply through. So we'll have 2 to the x times 2 to the 3 minus 3x is equal to 2 to the negative 2, right? So again, when we have an exponent to another exponent, we multiply the exponents. Then when we multiply two terms with the same base, we add the exponents. And so 2 to the x plus 3 minus 3x means 2 to the 3 minus 2x is equal to 2 to the negative 2. And now the reason from the beginning to write everything under a common base was that with a common base on both sides of our equal sign, you might notice that we can just equate our exponents, and that becomes a very simple equation to solve. The exponent 3 minus 2x must be equivalent to the exponent of negative 2. And so negative 2x is equal to subtract 3, negative 5. And so x has a value of positive 5 over 2. And there we go. Okay. For number 2, this took me a second to understand how it was set up at first glance. What we're going to do is move everything on one side. So subtract as such. So we'll have on the left-hand side 9 to the x minus 3 to the x minus 6 is equal to 0. And now maybe this will start to look like something you've dealt with before. This is actually a quadratic equation in 3 to the x, because we can write 9 to the x as 3 to the x squared. Now, if that is not obvious immediately, let me convince you, because 9 to the x is the same as 3 squared to the x, right? Just writing 9 as 3 squared. And now when we have an exponent to another exponent, we multiply the exponents. So that's 3 to the 2x. And then I can kind of just go backwards, but make the x on the inside and make the 2 on the outside, and that becomes 3 to the x to the 2, and that's what I suggested we write it as, to make this look like a quadratic equation. And I say that because if I make a substitution, if I let's say some other variable, let's say y, be equal to 3 to the x, then we have y squared minus y minus 6 equals 0. That I know is something you have dealt with before. So let's make this substitution just to make our lives easier. We'll have y squared minus y minus 6 is equal to 0, right? And that's simple enough. We can factor this, what adds to make negative 1, and simultaneously multiplies to make negative 6. You know that's y minus 3 times y plus 2 is being equal to 0. And that means that our solutions are y is equal to 3 or y is equal to negative 2, right? But we're not done. Our equation started in the unknown variable x, and so we should go back to that. We should de-substitute. And so if y is equal to 3, then 3 to the x is equal to 3. And if 3 to the x is equal to 3, 3 is the same as 3 to the 1. And so that means that our solution in x is that x be equal to positive 1. For the second proposed solution. We have y is equal to negative 2. That means that 3 to the x is equal to negative 2. And if you know anything about exponents, a positive base to any exponent can never become a negative value. And so all that means is that we get no new solutions from that one. And so our one and unique solution to this equation is x is equal to positive 1. We can check that. 9 to the 1 is equal to 3 to the 1 plus 6. 9 is equal to 9. That obviously works out. And so there you have it. So I hope this helps, and thanks for watching.